you guys ever wondered what causes the degradation of plastics in the open air? Or will these plastics will be susceptible to fire? Or have you guys ever wondered why old cables and old plastics casing will be easy to catch fire? Now, I will explain my study, which focuses on examining the degradation of plastics that is left outside in the open air and its fire properties. My study is about polyvinyl chloride degradation study due to exposure to heat, UV, and humidity. So for the abstract, PVC is inexpensive and has great qualities which make it popular in homes and industries. Outdoor PVC is exposed to sunlight and rain and degrade over time. Eventually, fire performance and aging are dots. Thus, it is crucial to know how each aging agent, which are heat, UV light, and humidity, will affect the fire properties and fire characteristics and which agent has the most influence. PVC was aged at 100 degrees Celsius in an oven under UVC light and in water for 1, 2, and 4 weeks. And then unaged and aged samples were sent for TGA and burning tests. TGA findings were used to determine the activation energy and emission temperature, and aged samples displayed a smaller TGA curve and DTG peak than unaged ones, and aged samples had a shorter time to char and lower activation energy. UV aging has the most harmful impact on degradation of PVC, as its fire properties are lower than those of other aged samples. This research indicates that outdoor aging affects fire characteristics of PVC, and UV aging damage the material more than heat and humidity. And these are the terms that I should explain. The first one, it is the material degradation, which is an irreversible alteration of chemical or physical properties. And second is accelerated aging, which is a method of introducing materials to a realistic simulation of long-term use by deliberately increasing the severity of exposure. Next is thermal aging, which is a molecular impairment after exposure to high temperature. And next is UV aging, which is exposure to UV radiation. And the last one is moisture aging, which is exposure to high relative humidity. Now, the reason why I choose PVC in this study is because PVC is widely used in industrial sectors and applications. But the combustibility of PVC is very concerning because there are many reported fire accidents around the world, such as in USA, 11% of residential fire accidents was from worn-out cable insulation and sheath, and less than half of fire accidents in India and China originated from oil buildings. And these are the focus of fire accidents from wire or cables. And the problem of HPVC arises when there are accidents from solar panel, which has PVC casing. And then there is also no studies on fire properties of H material that is degraded by heat, UV, and humidity, because previous studies only focus on mechanical and physical properties, and fire behaviors of H materials are vital to be studied to ensure high safety level. And these are the flowchart for my methodology. First, I will put PVC bond into three different setups to simulate thermal, UV, and moisture aging. And for thermal, I will be using vacuum oven at 100 degrees Celsius. And for UV, it is exposure to UVC radiation. And for moisture aging, it will be submersion in normal water. And all this aging will be for 1, 2, and 4 weeks. And then all these samples will be evaluated for their fire properties and will be compared with one another and also unaged PVC as the control. And there will be 4 analyses, which are thermogrammetric analysis, activation energy determination, ignition temperature, and time to char. And all these results will be analyzed, and the aging agent that has the highest influence on the degradation will be determined. And moving on to the last part, and these are the results obtained from the analysis done. And for the TGA, each aging agents are compared, and we can see from the graph all lines representing 1, 2, and 4 weeks of aging shows lower onset temperature, which means they start to degrade at lower temperature as compared to the black line, which represents the unaged PVC. And when looking at the DTG graph, each aging agents are compared. We can see from the graph, yellow lines, which represent 4 weeks of aging, shows the lower peak at thermal and UV as compared to 1 and 2 weeks. It proves that the longer the aging, the higher the degradation of the material. And from the last two graphs, the comparison between each aging agent in TGA and DTG shows that blue lines, which is UV aging, has the lowest curve and peak, which shows that UVH sample has the weakest performance in fire stability, and it shows that the UV aging has the most influence on the degradation of thermal properties. And then, from the activation energy that is determined using Coates reactor method, the performance of thermal H PVC is reduced by 61%, and UVH PVC by 70%, moisture H PVC by 59%. And in overall, an H PVC is 2.81 times higher to ignite than H sample. And from trend, it can be concluded that as the duration of edge is longer, the activation energy of the sample will be much lower. And next, for the time to char, okay, as the time taken for char formation is thermal HPVC is reduced by 25%, and UVH PVC is by 52%, and moisture H PVC by 1.32%. Time to char will be shorter as the edging duration is longer. This it means that the fire resistance on the surface has been degraded. And from the ignition temperature of the material, all the temperature will decrease along with increasing edging time. And in average, the thermal PVC has 2.39% low ignition time, and UVH PVC is reduced by 8.11%, and moisture H is by 2.96%. However, these ignition time values are not the exact representation of actual ignition temperature for the samples, since these values are only obtained from J curve as an indicator for the performance. Thank you.